And then year 10s, in this video, we're going to go through exercise 8B, which really is to look at set notation. So how to use certain symbols, specifically union and intersection. Let's have a look at a couple of terminologies that we should know here. A set, okay, a set is a collection or a group or groups of outcomes. Okay, now that can include numbers, letters, or other objects. Okay, so it's just a group of objects or groups of outcomes. A sample space, okay, a sample space is essentially all the possible elements that you can have. Now, sample space can also be written as with the symbol, the epsilon symbol. Okay, sometimes you can use it as the capital S. You can also use it as a capital U for universal set as well. That's what it's also known as. So either way, all these symbols here, I'm going to just write here universal set. So it's not only just a set, but it's universal, meaning it's got everything in it. Yeah? Complement is an event that has elements that's not a part of a set. Okay, so normally denoted with a dash. So like, for example, set A with a dash. I forgot to mention, if you didn't realize, when we denote a dash, one of the ways that we denote a set, when we denote a set, we always use a capital letter. Capital. Okay? So for example, if you roll a dice, when you roll a dice, what are the possible outcomes? You'd say it's 1, 2, 3, 4, 5, 6, right? And then let's say the set A, so group A, is the even numbers. So then it'll be 2, 4, and 6, like that. Okay, so we use a capital letter to say that that's a set or a group. A null set is a set with no outcomes or elements, and is symbolized by a 0 with a dash / crossing through it. Okay, that's the symbol for a null set. An intersection is when two sets have common elements, and it's denoted with an inverted smile. Okay, whereas a union is then the cup shape, which is kind of like this U shape. It's union. It's when two sets have combined elements. I'll explain this soon. So these two are the key terms for today: intersection and union. Two sets are considered mutually exclusive if they have no elements in common. Now, if you're wondering what I mean by elements is another word for outcomes. Okay, so no outcomes in common. For example, you would say mutually exclusive means that do they have anything in common? See, intersection. So A intersection B, is there anything in common? No, there is nothing in common. Notice I didn't use 0, because if I said 0, then the number 0 is in common. Get me? So you got to use a null set for that. Unless you're talking about probability of A intersection B, then the chances are 0. There's no chance that two things, if they have nothing in common, when there's no chance of it occurring, A and B won't happen, right? All right, so let's do some examples just to tie things together. You've got the symbols and terminologies there. One of the two key diagrams that you can learn is called a Venn diagram and a Carnot maps, or also known as two-way table. I'm going to fill out the region here. There are 4 regions in a Venn diagram. It's got the overlapping region. So this is where both A and B have something in common. So we then call that A intersection B, because they both, A and B, have something in common. Whereas in the next region, that I'm coloring in blue, this is the second region. This is where A does not have anything in common with B, but everything outside of A, though, so think of A, this is A, everything outside of A includes that blue region. So everything that's not A does have in common with B. And that's why we say this region is not A, but is in common with B. So it's specifically in that region. Okay. Otherwise, if we said not A, if I just said, where's the region that's not A? Well, all of this is not A. Get me? All of this is not A. But I didn't want the white region. I would just want just within that B section. So it's B, but I don't want to include the yellow region. So I say not A, intersection B. Let's have a look at the next one. What about this green region here? So what about from here to here? So this part, I just want A only. I don't want any parts of B included. Well, that region there is A, but not B is in common. Okay. And then obviously everything on the outside is where both A, and not B are in common. So I would color everything that is not part of A and is also not part of B. And so that's the outside region in white. Okay. Now the reason why I'm labeling out these with these symbols is because the two-way cardinal maps actually puts it nicely. So the 4 regions I just named, so this is region 1, region 2, region 3, right? And then there's a 4th region. Well, it can actually fit in these regions here. So let's have a look. Where is A intersect B? Where do they both have in common? Well, that's region A. Okay, so that's 1, A intersection B. So this section is A intersection B. Then what about not A that intersects with B? Well, if it's not part of A but intersects with B, well, that's here, right? So hence, not A intersects with B, which makes sense that if you added the number 1, region 1 and region 2, if you added region 1 and region, not A, oh, sorry, not A, not A, but B, yeah, so that's right. Region 1 and 2, if you add it together, if you add these 2 regions together, it's like adding the yellow and blue together, you actually get all of B. That's why the last row, when you add all the regions together, should give you B. Right? So that's B there, then this becomes B too. That's full of B. Then you do the same thing. Well, what about the green region, right? The green is A, but not part of B. So A, but not part of B, this is where the next region is. A intersect B dash. Now, interestingly enough, if you added the number 1 and 3 together, you would get all of A. Whoops, what did I just do there? All of A. So there you go. You got A, B, and then the last region, obviously this is not A, intersect not B. That's your 4th region there. And if we work it all together, this is not A, this is not B. But clearly if you add them all together, it should give you a total of 1 because that's 100% of everything. True? All right. So that's how the 2 Venn diagram and cardinal maps can link to each other, and that will help you solve problems later on. Now, last symbol for today, in terms of your notes, you got this little N. What does that N mean? That means number. They call it cardinal number. Cardinal number. But it just means how many elements are there? How many elements in the set? Okay, so in A intersection B, so they say, what if A intersection B is 1? What is, so I'm going to draw a 2-way table so you can visualize this. So A dash, B dash. A intersection B, let's say there's 1 number there. So there's 1 number in A and B. Let's say the number of elements in A and not B, so A not B is 3. So that means for A, there's a total of 4 units there, right? So if I were to draw a Venn diagram, you can probably picture this now. A, and then this is B. Clearly, A and B share 1 digit. A, but not B, clears 3. So if you add all of A together, you can see there you should get 4 units. Then if I did follow on with this one, this is number of not A intersect with B. Well, what is not A and then is also part of B? Well, not A, but part of B is 4, and the other one's 2. So if you fill out the numbers now, that's 5, 5, that's 6, and they all add up to 10. So there must be 10 people in total. Now, let's have a look. 4A, so this is 4. I should write that in purple. This is 4, and the last number is 2. All right, let's answer the question. The question is, how many elements are there for A union B? Now, if I union A and B, can you see if I color, this is all of A, and then I color all of B as well, well then that's 3 plus 1 plus 4, isn't it? 3 plus 1 plus 4, that should give you all of A and B, and that's what, 8. But notice, which regions were those? This is 1 plus 3 plus 4. So in the cardinal maps, you can actually work out for the union just simply adding those 3 regions together, and you will get all of A union B. Okay, so that's the difference between union and intersection. Intersection is obviously when do they both simultaneously occur, whereas union, you essentially include them all together. So here's an example. Let's do an example here. From a pack of 20 dogs, 9 enjoy fresh meat, 12 enjoy dry food, and 7 enjoy both fresh meat and dry food. So illustrate this information in a Venn diagram and two-way table. So I've got a two-way table there, and I like to do two-way tables first, but I mean you can draw yourself the 2 circles if you want, and you can call them D for dry food, and then M, which is fresh meat. Okay, so here we go. If I want to answer the question, they said from a pack of 20 dogs, so there's 20 dogs in total, 9 enjoy fresh meat. 12 enjoy dry food. So it sounds like dry food is 9. Fresh meat, so total of fresh meat is, that's 9. And then 12 enjoy dry food. Sorry, my bad. It's the other way around. And then they say, and 7 enjoy both fresh meat and dry food. So 7 enjoy both. So if I got this table here, remember the total has to add up to 20. This means this is 8. This means this is 11. And you can actually start working things out. 7 plus 2 is 9. 2 plus 6 is 8. And then 5 plus 6 is 11. So that means I can now fill in the regions. M intersection D must be 7. So that's where they both have in common. Region where there's D but not M, so D but not M is 5. And then the region where it has M but not D, which is 2. And then everything outside is 6. There you go. So now I've drawn my Venn diagram and I've drawn my cardinal map. So that's question A. State the number of dogs who enjoy fresh meat only. So fresh meat only is clearly just this region. Just that. So clearly 2. The answer is 2. State the number neither fresh meat or dry food. Well, clearly it's 6. Everything outside of that. Anymore? No. And then E, find the probability that a dog chosen at random from the pack will enjoy fresh meat. So essentially you're saying find the probability, PR, of fresh meat, which is M. And so how many people like M? There was 9 of them out of a total of 20. So 9 out of 20. That's your chances. 9 people that you can pick that will like fresh meat. They didn't say fresh meat only. They just said fresh meat. Whereas the next one, it says, what's the probability of dry food only? So dry food is D, but I don't want anyone who doesn't like fresh meat. Wait, is that right? D, dry food only? Yeah. So everything outside of M. So in that region there, well, let's have a look. Dry, but fresh, not fresh meat is then 5 people. So you got 5 people out of your 20, which actually works out to be a quarter. So about a quarter of you would prefer just dry meat only. What about both fresh meat and dry food? Well, that means you're looking for dry meat and dry food and then fresh meat. So when you look at the table there, you can see that's 7 out of your 20. That's your chances there. Okay? And that's essentially one of the key things to get your head around the word and the word or. When you see the word and, you should think of intersection, and or, you have a choice, and hence you combine all the possible choices. And is trickier because both of them have to occur. So not only does M need to occur, so fresh meat, but dry food has to also be involved as well. Okay, so that's why that region is very specific for A and B. All right. That's it for today's video, I believe, unless there's further things that I can explain, but I'm pretty sure that's all you need to continue.